Hi, I'm going to talk today about radiocarbon dating using compound-specific approaches, specifically with respect to the chronology of the Middle to Upper Paleolithic. And this is work that I've been involved in for the last 10 to 15 years, I suppose, in my previous research life, which was in the University of Oxford. Radiocarbon dating is the most accurate method that we've got for dating the past in archaeological terms. As many people know, it relies upon the measurement of carbon-14, which is an unstable radioactive isotope, which has a decay rate of about 5,500 years. The half-life is well established back in the 1950s. And when it comes to dating old samples, it can be very difficult. And this is because of the exponential pattern of decay. So by the time one gets back to 30 to 50,000 years ago, dating becomes very challenging because of the small amount of radiocarbon that's left. And this means that when you date old things, tiny amounts of contamination can have a big effect because there's not much radiocarbon left. So potentially, there is a great deal of problem for old contaminants to be introduced and to be difficult to remove. And these fall into two main categories: soil substances from humic sources and conservation materials from things like glues and consolidants in museums and universities. So I've been at the forefront of working on material on approaches to remove these types of contaminants. One approach that we developed and applied is the ultrafiltration method, which allows us to separate small contaminating molecules from larger molecules of collagen. And this has seen some significant developments in our ability to clean up samples archaeologically, but not in all cases. And so that's why we've been working on developing single amino acid dating using high performance liquid chromatography. Chromatography is a very established method, and it involves the separation of analytes using solid phase columns. We've been working on this to separate the amino acids of collagen and to isolate just the hydroxyproline. Hydroxyproline is a biomarker for mammalian collagen, so it's a very attractive amino acid to separate. It's about 10% of the total amino acid pool, and so it's gives us the ability to separate contaminants from the bones that we date. Some examples: here's the site of Sunghir in Russia. It's a mid to upper Paleolithic burial, one of the earliest symbolic burials that we have in the archaeological record, with individuals. These are three, a man and two adolescents, buried in exceptionally wealthy circumstances with beads and so on. Previous dates have been very variable from the Sunghir burials, the three principal ones. You can see they range from 19 to 27,000 in the case of Sunghir 1. Despite ultrafiltration being used, this is a good indicator that there's contamination in the bones. And in fact, when we see the bones themselves, we can immediately tell that there is some additive on the surface. Here's this skull of Sunghir 1 on the left. And what they've added here is a polymer which comprises several different types of material, including tree sap and formaldehyde and ethanol. And they painted this onto some of the bones. And this is why the dating of the bone is proven to be particularly difficult. So for some of the burials, here are some of the results we obtained using hydroxyproline extraction, which you can see at the very bottom in blue. And you can see that all of the hydroxyproline dates are older than the previous dates established. And this is generally associated with more successfully removing contaminants. All of the dates cluster around the 34 to 35,000 year old range. The Vienna Neanderthals are amongst the most recent Neanderthals that have ever been directly dated, but we've been suspicious of these results for many years. So two main bones here, the parietal bone on the right and maxilla on the left, date to around 28 to 29,000 radiocarbon years BP. When we redated these using ultrafiltration, those are the dates that you can see in orange here. The dates got marginally older, but they still were contaminated, and we can tell this by the carbon to nitrogen ratios. It was only when we extracted hydroxyproline that we got dates that were more than 10,000 years older than the hydroxyproline, than the ultrafiltered dates. And these, again, are the most reliable dates that we have for these Neanderthals and suggest that they were older than we thought. At Kostyantki 14 in Russia, a well-preserved skeleton called the Markina Gora Kostyantki 14 skeleton was excavated by Rogachev in 1955. In the side of the grave cut, the Campanian ignimbrite was found, which is around 39,000 years ago. And so we knew that it was a Paleolithic age, but the radiocarbon dates that were first obtained were between 3,500 to 4,500 years ago, the Neolithic. And this led to a big debate in Russian archaeology about whether the bones were actually that old. We extracted hydroxyproline from the Kostianki specimen and got a date of 33,250, perfect for its context. But for the first time, we've been able to reliably date that specimen. And in the Crimea, at the site of Kabazi 2, one of several sites on this large gorge, we find the Mycokian Mousterian Neanderthal industry and some very late, surprisingly late dates for inferred Neanderthal presence in the Crimea. These dates are much more recent than the established dates for the disappearance of Neanderthals at around 40,000 years ago. You can see they go as late as 35 to 36,000 years ago. And this has led to suggestions that this might be a refugium for late surviving Neanderthals. Unfortunately, it's not, because the contamination that has been found in these bones probably from soil humic sources. Here's a comparison of individual dates. Blue are the hydroxyproline dates, red are the ultrafiltration dates, and gray are the original collagen dates. And you can see that all of the blue dates are older than radiocarbon time, older than 50,000 years ago, suggesting the previous dates were sadly completely contaminated. So we've shown that extracting single amino acids can produce reliable contaminant-free dates. This doesn't mean that all bulk dates are erroneous. Often the human bones are the treated ones, and these are where we find the contaminants. Compound-specific approach should be the method of choice for dating really important archaeological bones. And it really is the future for this type of science. I'd like to thank all of my colleagues who worked on the PaleoChron project, from which this work stems, particularly Dr. Thibaut Deviez, who's top left, who worked extensively on the dating of single amino acids, building on previous work in the Oxford Radiocarbon Accelerator Unit. Thank you very much.